Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at standard deviation. So when you calculate the standard deviation, you come up with just one number. That number is a measure of how spread out the data is, and it's a much better measure of spread than is something like the range. The standard deviation is basically the average distance of each score from the mean. So if you have a set of scores that has a high standard deviation, that means scores were spread out and they were quite far from the mean. If you have a low standard deviation, it means that scores were close together and they weren't far from the mean. So how do we actually calculate the standard deviation? Well, we use either of these formula. They're very similar formula. They only differ in that one you divide by n and in the other you divide by n minus 1. So how do you know which to use? You use this one when dealing with population, this one with sample. So what's the difference between population and sample? Population includes everyone, sample just a subset, just some of them. So for example, let's say I wanted to know the standard deviation of the heights of year 10 students at Lynham. I'd be talking about the population if I included everyone in year 10 at Lynham in my calculations, and I'd be talking about a sample if I only included some year 10s in my calculations. So if I include everyone, I divide by n. If I include only some people, I divide by n minus 1. All right, what do these formula here actually mean? Well, this symbol here means sum. Xi refers to each individual score. So x1 is the first score, x2 is the second score, and so on. X bar means mean, and n is the number of scores. So basically what we're doing, we're taking each score, subtracting the mean, then squaring that number, adding up all these numbers, dividing either by n or n minus 1, and then square rooting our final answer. Those steps are exactly what I've written there. So we're going to follow these 6 steps. They probably don't make a lot of sense until we do an example. So let's do an example and calculate the standard deviation of these numbers here. Your first step is to calculate the mean. So to calculate the mean, add up all the scores, divide by how many there are. So in this case, the sum of the scores is 290, divide by 5 because there are 5 scores. You get 58. The mean here is 58. So next step, take each score and subtract the mean. I suggest drawing up a table for this. So in your first column is xi. That is all of the scores. So step 3, we need to take each score and subtract the mean. So this means score subtract mean. So the mean was 58. So we go 32 minus 58, 40 minus 58, 58 minus 58, 74 minus 58, and 86 minus 58. So step 2 is done. Now step 3 says square each of these. I need to take each of these numbers and square it. So negative 6 squared is positive 676. Remember when you're doing this, if you square a negative, the answer is always positive. So I've now done step 3. Step 4 is I add each of these. I need to add this column here. So adding up this column, I get 2040. So step 5 is where it's just slightly different if it's population or sample. So if I was calculating the population standard deviation, I'd take 2040 and I'd divide by n. N is the number of scores. So I would divide by 5. Now, if I was calculating the sample standard deviation, I divide by n minus 1. N is 5 because there are 5 scores, so n minus 1 is 4. Whether I'm calculating the population or sample standard deviation, my final step is to square root. So putting this in my calculator, the population standard deviation is about 20.2. The sample standard deviation is a little bit higher at 22.6. Obviously, the more scores you have, the less of a difference there will be between these two. And in general, the answer you get is not going to be a nice number. But that is it, 22.6 and 20.2. Each of them is just giving us an idea about the spread of the data. So because all the scores between 32 and 86, it says, there's quite a spread here. That's quite a high standard deviation relative to the scores. So the scores, they're not really clustered together. They tend to be far from the mean. And that's sort of what we'd expect. If this was like scores in a class test, you can see that the scores are quite different. There's quite a range of scores here. All right, let's now look at z-scores. So the z-score formula says the score minus the mean divided by the standard deviation. The z-score formula calculates the number of standard deviations a score is above or below the mean. If it's above the mean, the z-score will be positive. Below the mean, it will be negative, and a z-score of 0 means that it's equal to the mean. So these scores will become very important for you when you go to college, because your z-scores plus your AST basically determine your ATAR. The z-score just says how you went sort of relative to everybody else. So if you get a z-score of 2, that means you're 2 standard deviations above the mean. That's really, really good. That's really high. On the other hand, a z-score of -1 would mean you were 1 standard deviation below the mean, which is not good. But in general, you're not going to get z-scores of like 10 or anything like that. That's, almost impossible. Your z-score is going to be low numbers, generally between -2 and 2. But hey, if you're really awesome, if you do say really awesome in a test compared to other people, you could get a z-score of 3. But you're never going to get a z-score of 10. All right, let's look at some calculations. Let's say I've got 86 on a test, mean 60, standard deviation 15, calculate my z-score. So the z-score is simply you take the score, you subtract the mean, and divide the standard deviation. So you can put that straight on your calculator. It's about 1.73. So on this test, I was 1.73 standard deviations above the mean, which is pretty good. All right, let's look at a question here in which we manipulate the formula. Suppose that Liam's 180 centimeters tall and the z-score of his height is -0.2. Let's say that's compared to all Australian men. If the mean is 182.8, calculate the standard deviation. So we're calculating the standard deviation of heights. We're still going to use this formula. So z-score, which we're told was -0.2, equals score minus mean over standard deviation. So we just have to solve this equation to find the standard deviation. So just rewriting that top, of course, 180 minus 182.8 is -2.8. Of course, a z-score of -0.2 means this guy is below the mean. So how do I solve this equation? Well, the easiest way is to move the -2.8 and fraction line over there. So the standard deviation, will be -2.8 divided by -0.2. And if you put that in your calculator, you get 14. So here, the standard deviation of heights is 14. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.